Section 8.2 is linear equations in two variables. I can find solutions of equations in two variables. An example of an equation in two variables is 2x minus y equals 5. A solution of the equation in x and y is an ordered pair x and y that produces a true statement when the values of x and y are substituted into the equation. So both sides equal the same thing. On example 1, we're going to tell whether the ordered pair is a solution. So everywhere that I see an x, I'm going to write 1. And everywhere that I see a y, I'm going to put in a negative 3. And I'm going to check and see, does this equal 5? So I'm going to keep the rest of my equation exactly the same. And I'm going to substitute in a 1 for x and a negative 3 for y. 2 times 1 is 2, minus a negative means plus 3 equals 5. 2 plus 3 equals 5. So 5 does equal 5 when we checked there. So this is a solution. Again, keep in mind, guys, that if there's not a number in front of a variable, it's like negative 1 times. We're going to check b here. So x is 4, y is 7. 2 times, instead of x, I'm going to write in 4, minus, instead of y, I'm going to put in 7, equals 5. And again, remember, it's like a negative 1 times the 7. 2 times 4 is 8, minus 1 times 7 is negative 7. And I get 1 equals 5, which is not true. So 4, 7 is not a solution. This ordered pair, not a solution because 1 does not equal 5. Okay, feel free to pause here and give these a try if you'd like. We're going to check to see whether the ordered pairs are solutions of our equation. Okay, x, y. So instead of writing an x, I'm going to plug in a 0. And instead of writing a y, I'm going to plug in a 4. And we're going to check and see, does it equal negative 8? 3 times 0 is 0. 2 times 4 is 8. So 0 plus 8 is 8, which does not equal negative 8. So this, no. X is negative 2, y is negative 1. 3 times, instead of x, I write negative 2. Plus 2 times, instead of y, I write negative 1. Negative 6 and negative 2 give me negative 8, which does equal negative 8. That checks. This one is a solution. 3, I have x and y. 3 times 4 plus 2 times negative 12 equals negative 8. We're checking that. Is that true? I have 12 when I multiply here. When I multiply here, I get minus 24. And I get negative 12 equals negative 8, which is not true. So no, this is not a solution. Last one here, x and y. I have 3 times x, which is 10, plus 2 times y, which is negative 19, equals negative 8. 30 minus 38, which gives me negative 8. And that is true, so yes, this is a solution. For the 1859 volcanic eruption, lava traveled 32 miles to the Pacific Ocean at an average speed of 4 miles per hour. The lava's distance d in miles from the ocean, t hours after it left the volcano, can be approximated by the equation d equals 32 minus 4t. We're going to make a table of solutions for the equation. So we're going to plug values in for t and get values for d. And when we're talking time, the smallest t value we can use is 0. And then we can use anything positive. We could do even like a 4.5 if we wanted. Okay? So when I do that, I take my t values and I plug them in for the t spot. And the number that I get when I simplify that right side is going to be my d value. So here when I plug in 0, I take 32 minus 4. Instead of a t, I write 0, which gives me 32 minus 0, which gives me 32. And what it equals is d. So at time 0, so when the volcano erupted, my distance was 32. Same idea with the 1. I substitute my t value in for t, and I simplify it to get my d value, which here was 28. Again, I have t, 2, so I plug it in. And we could have picked any t values here, as long as they were positive, because we can't have negative time. So if I wanted to, I could have picked 10. Okay? I could have picked 100. I could have picked 1.75. We could have picked any t values. Some of them are going to work a little better than others, and we'll see that here in a minute. 4.5, which is 18, which is going to give me 14. So what this is telling me is at a time of 4.5 hours, my distance is 14 miles. Here we have to be careful. At 10, it tells me that my distance is negative 8 miles. Can I have a negative 8 for my distance? No. So that one didn't actually work in this particular situation. We can only go 32 miles because that's how far away it is. After that, we reach the ocean. Okay, so the distance from the ocean is 0 at that point. And that's kind of what we want to figure out here with B. So how long did it take the lava to reach the ocean? Well, we know it didn't take 10 hours because at 10 hours it was already there. And at 4.5 hours, it wasn't there. So here we're just going to try a couple more values. We could try 6, let's say. Which is 8, which means I'm getting closer. I'm trying to get my distance to be 0. I don't want it to be any miles away from the ocean. I want it to be there, so I want that distance to be 0. So I'm closer than I have been, but I know I can't go to 10. That's too far. 6 is closer than 4.5, which is closer than 2, which is closer than 0. So we could try 7, we could try 8, we could try 9, somewhere in between 6 and 10. Here, when I plug in 8, I get 0, which is what I'm looking for. How long did it take the lava to reach the ocean? Distance 0 means it's 0 miles from the ocean. It means it's there. And that happened at time 8. So 8 hours. And this is kind of a guess and check for now, guys. Another way that we could have done that problem versus a guess and check that would have gotten us our answer is we could have graphed it. The graph of an equation in 2 variables is a set of points in a coordinate plane that represent all the solutions of the equation. An equation whose graph is a line is called a linear equation. So once we graph an equation, guys, we can see all of our values. So rather than guessing and checking to find what we're looking for, we can look at our graph and pick out our values. So we're going to graph this the same kind of way as we just did with that table of values in the last example. But here, since we don't have any specific situation, we can plug in any x values we want. So the ones that I'm going to plug in are -2, -1, 0, 1, and 2. And those are usually going to be the values I use. They're small numbers to work with. They're numbers on both sides of 0, so it lets me see what's happening everywhere. And they're easy to fit on my graph when I have it centered at 0. So I'm going to take these x values, plug them in for x, and whatever I get is going to be my y value. So here I'm going to take 2 times x is -2 minus 1. -4 minus 1, -5. I'm going to do the same thing, guys. I'm just plugging it into my function here. 2 times, instead of x though, I'm going to write -1. -2 minus 1, -3. 2 times my x here is 0, minus 1, 0 minus 1, -1. 2 times 1, my new x, minus 1 is 2 minus 1, 1. 2 times my x value, 2, minus 1, 4 minus 1, 3. So now that I have some ordered pairs here, I'm going to graph them. X is -2, y is -5. X is -1, y is -3. X is 0, y is -1. X is 1, y is 1. X is 2, y is 3. Now, I'm going to take a straight edge, like a ruler or the edge of a note card, or some kind of a straight edge. Here I'm just going to use my draw tool. And I'm going to connect those dots. And we want to go as close to right through them as we can. I'm going to put arrows on the ends to show that it continues. Okay, if you do this, guys, and your graph doesn't, your straight line doesn't connect all 5 points, it means you either need to check your points or like how you graphed them or how you calculated them. Okay, and we could have picked any points here. We connect them because we could have picked 1.5 and gotten 2. We could have picked 0.25 and gotten -0.5. We could have picked 100, okay, and gotten 199, and that's why we have to put the arrows here to show that it continues. So this same pattern is going to keep going. Feel free to pause here and give these a try if you'd like. Table of values. We pick numbers to plug in for x so that we can find some y's. We need ordered pairs. So I'm going to use -2, -1, 0, 1, and 2. I'm going to take my x values and plug them in for x. So I take my x values and I keep the rest of my equation exactly as it's written. So 2 times my x values, 2 times my x values, 2 times my x values. Here I get -4, -2, 0, 2, and 4. And remember, guys, these are like ordered pairs. X, Y, X, Y. So I graph them as ordered pairs. Here, X is -2, Y is -4. I have a point. X is -1, Y is -2. Point. 0, 0 at the origin, I have a point. 1, 2, I have a point. X is 2, Y is 4. I have a point. We connect our dots with a straight edge. And again, if our straight edge doesn't connect our points, we either calculated them wrong or graphed them wrong. So we need to double check that. Arrows to show it continues. And I'm going to pause this video here and I will finish this section in another one.